Hello everyone and welcome back. So now we're going to do a different project that involves continuously emitting fluid. But before we do that, I wanted to show the flip mesh quickly, and this is how it looks like. And everything is working as expected. So this would be the mesh that we sent to the render. Cool. So I'm gonna keep this file and reuse the same network pretty much. And the first thing I need is I'm going to import a new collision geometry. And let's find that. And this is a high-res geometry of a destruction destruction scene I did. So let's zero this out. And I'm going to move it up. And let's check the scale. So we want always to use meter, and it looks like scale is quite big, so I'm gonna reduce this to be maybe 3 meters in total. Let's move this. I think it's fine. No, a bit more. Okay, and let's move it up. Some pieces are still floating, so it's not 100% realistic, but the idea is I want to have some kind of flooding behind this that hits the everything pretty much. And I wanted to explain the importance of the collision geometry as well, using the VDB from polygon technique. Okay, so let's swap this collision. Let's first check where our box is. Okay, and we're going to let's copy this node and increase this just to make sure. I'm going to use a big voxel size just to make sure that everything is working. For the VDB from polygon to work, we have to make sure that everything is watertight. I'm not going to dive too much into this, but later we'll talk about various techniques to properly generate volume representation out of geometry, even complex geometry or things that have weird topology on them. Okay, so we need to see enough details here. We can go higher. Let's try 0.05. Okay, so I'm gonna call this out collision VDB out flood collision VDB, and this is going to be the geo. And when it comes to DOBs, the lighter the geometry, the better. Okay, so if we can create a cleaner geometry out of this, the cleanest we can get with the least amount of points, the happier DOBs is going to be. So what I'm going to do is I'm going to use a VDB convert and actually convert this SDF back into geometry. It's not going to be perfect, but it's going to be much lighter and much cleaner to use. So here, if we take a look at the data, cool, and we can actually use even a higher version of this to just create the geometry if we need to. And I'm going to connect that. Okay, and then for the domain, I'm going to use this guy just to fit in this, just to get enough to fit the domain to encompass this, and pretty much some extra area, some extra padding, so that when we emit the fluid, it's gonna find room where to grow. So let's copy this guy. I'm gonna call this flood, and I'm gonna copy this node here. I'm gonna delete it. Delete this particle separation increase. I don't need to have high-res separation here. And let's template the geometry. What happened? And let's tweak the size of this. Again, the bigger, more points, bigger volume field, more data. Very simple. And let's check the ground level. Which one is 0? I need to move the geometry, so let's do that. Okay. Tiny bit more. Cool. I'm gonna move this up here and give it some room, and I'm gonna create a source behind this that emits in this direction, and it's gonna interact with all of this, and we'll see how it goes. Actually, let's tighten this up and we'll use boundaries. We'll have these as if they're actual walls and use them to collide with. Okay, so I'm gonna create a floating window of this and dive inside this guy. I'm going to change the color. Here, and let's dive inside and make sure the particle separation is high, because we're going to change the domain quite a bit, and if we have very high points, it can slow down. Well, it will slow down, so just want to be careful with that. And let's update the links to the new box. We could have used the box as well for this. Okay, and that's pretty much it. Now we need to update the collision geometry as well. So let's do that. Flood collision and flood collision VDB, and we don't need deforming geometry. Cool. And this guy, we don't need, right now it's set to sub path. We don't need to pre-fill it. We're gonna dynamically import the fluids inside the scene. So let's do that. Let's create a box, and let me template this geo, and let's create a box. Gonna move it here. And that's pretty much it. We're gonna convert this into a fluid source, and for that we're gonna use a flip source node, and this is new in Houdini 17. And once we plug that in, you can see it made particles as well as a surface field. Now if we hit the W key, you see it's not showing us points, just the surface field, and that's very important for the flip source to work. It needs to know, it needs an SDF to work properly, and that's what this is. It's a science distance field. And we have particle separation. We're gonna keep the voxel size as it is for now. We don't need to change it. And we have to make sure that this is set up to a flip source. You see, when I did the change, let me do this again. This is a bit tricky, and if you're new to Houdini, it may confuse you. By default, it's set, this initialize is set here, but look at the tab. Okay, it's actually not reflecting this nor any of them. And I'm gonna copy one more node. If I change this to something, it's gonna change all that, and then if I change it back, that's when it starts toggling on the options. Okay, so it's very important to switch back and forth to get all the settings, all the default settings for that tab to work. Okay, let's create a null. Call this out flood source. And that's it. I'm gonna copy the particle separation. Actually, we're gonna copy it from the sim. So let's copy this guy, not this one. this one. And let's link it here. Okay, let's dive inside. I'm gonna create a volume source, and this is new again in Houdini 17. It's improved in Houdini 17, and all we have to do is set this to source flip, and then it's gonna set everything correctly for us. We don't have to change anything pretty much. I'm gonna copy the link of the source or the output and paste it here. And let's hit play. Make sure we're looking at the correct output. You can see the points there. If we hit play, we're gonna see them fall, but we don't have a huge emission at the moment, and it looks like the domain is outside. The box is outside the domain, so let's fix that. This is our node here. We'll call this domain. So I'm gonna include that. And let's go back in and let's change the particle separation and hit play. See, now the particles are falling. So we don't have any velocity coming in, so we need to change that. Now this node can give us initial velocity. I'm going to turn on enable velocity, and we need positive Z. That's our orientation. I'm going to set this to 20. If we dive inside, you can see now the points are shooting. Every frame it's going to continue shooting, and collision and all, it's going to work just fine. So let's do a few more things. Very important aspect is the sourcing in flip fluids, especially if you have continuous emission like this. We have to get enough velocity variation coming in to make variation between the particles, which will result in rippling details throughout the sim. But if we have them all coming in at the same velocity, the water is just gonna be flat all over. So we need to add as much variation in the incoming source as possible to create variation in the particles, so that when we mesh them, we get interesting details. And I'm gonna move this over here. And maybe up. And I'm gonna use a point velocity node. This is new in Houdini 17 as well. And I'm gonna turn on the add curl, and let's take a look at the velocity. This is the previous values. This is the new values. And it looks like it's not adding to the incoming, it's not appending to the incoming velocity, and it should have been. Keep incoming, yes. So initialization, I'm gonna set it to keep incoming, and here we're gonna add randomization, just noise basically. And I'm gonna use an offset equal to the dollar frame, maybe divided by 10, so that it changes every frame. This is too much. Let's change it to 20. Okay, the distribution of the point is also changing, so that's another factor, but I'm gonna keep this offset at 20. And you know what, let's do this. Let's put down a time shift, and I don't have to jitter. This is what's causing the source to change. Basically, I'm freezing it here, and this way I can look at the velocity. Yep, I like that. So we'll keep it, and we're gonna simply increase the points to 0.1. You see now it's white here, and we're not getting any blue values. That's because we need to remap the velocity. Right now the ramp that's been used only is not capturing enough informations here. So let's do that. If we select the flip object node and go under particles, this is the ramp where we can set the min and max, and right now it's using the velocity. I'm gonna set this to 25. Let's go back one frame. You see already we're getting more colors there. Set this to 50, too much, 30. And we can also change this to use pixels and change this to black background, which will show us more points basically, or a better representation of the water itself. So let's hit play. I think it's too strong. Let's go up and reduce this to 10. And I'm also going to do another one. So that, but this one I'm gonna give it a much bigger radius. Let's disable this guy. The swirl I want it to be much bigger, and the scale as well. And I want to create more breakups in the source. So like a huge shift in the direction of the source to make it one time emit this way, one time emit this way, and so on and so forth. But let's reduce this to 3, so it's not a huge change. And I'm going to lower the variation speed so it doesn't change. Yeah, something like that. And let's enable this. Now both of them, we're going to get a lot more interesting variation. I'm going to disable the time shift so we get jittering of the points. And let's go back in. You can see already the first frame. We have a lot more details coming in by just playing with the source itself. I think it's too much now. So let's go back and let's reduce this to 4. This guy to 3. And by just playing with the source, we can increase the amount of details drastically. Okay, and this is very, very important. I'm gonna change this to 6. I'm gonna change this to 4. I'm actually going to do one more velocity, and this one I'm gonna make it very, very fine. Like I want to increase make the variation a lot higher. And I'm going to increase the gain. See how much variation there is between the points now. And let's set this, let's keep it at 3. And the scale, I'm going to lower it to 1.5. So it's not huge. And I want to make it change much faster than all the others. So now we have 3 layers basically. Okay, let's increase the point. Let's see how much we get now. Let's take a look. We have 400, 500,000. I'm going to increase this quite a bit. 0.06. And let's hit play. And basically that's how it works. The collision technique is the same, and the source, we're going to use a volume source node. The main trick is the emission velocity, is the incoming velocity. There's not so much when it comes to sourcing other than playing with the velocity field itself. There's things that we can do inside the solver to increase the details, but the majority of it, if you have a river for example, the majority of the details are going to come from that river source, where you have to basically fill in the river with water, and the more variation you have in the source, the more variation you're going to get in the surface. Okay. So what I'm going to do is I'm going to copy this guy, and I'm gonna move it, create basically another source that is smaller, and this one I'm gonna rotate like that, just to add more breakups, that's all. And for the source, I'm gonna have it shoot up, and yeah, we'll set this to 4. We can take a look at the velocity vector. -2, something like that. Set this to 8 and -4, and we're gonna keep all this stuff the same. Keep it there. Come on. And we're gonna add this source. So volume source again, and we're just going to merge these two guys together. Paste that there, and set this to source flip. And as you can see, we have the surface field. We're not going to change that, but inside here, this is where the particles are coming in. We can decide to turn and off sources if we wanted to. So if we want to have them emit for 10 frames and then stop, we could key the activation there. Now, in terms of the flip source, the flip solver itself, there's quite a bit of options to tweak, and for now I'm going to go under receding and turn off receding. What this does is it tries to reseed, change the points every frame. We don't want this. It adds an overhead, and it doesn't help too much with the stability of the mesh. We have ways that we can get decent mesh out of this. And then the separation, we're not going to turn that. We're not going to turn this yet. I'm going to turn on vorticity, and let's see. And then here inside the velocity smoothing, the higher the value of the smoothing, the gooier it's going to look like a glue, basically. The more gluing we're going to get between the particles, going to feel viscous, and there is more attachment by blurring the velocity. And the smaller this number, the sharper the details is going to be. It doesn't mean we're going to get more details. It can start ruining the sim. But for now, I'm going to set it to half that. And let's see, narrowband, we don't need that at the moment. Narrowband is only useful when you have a whale, for example, coming out of the water, and you have a very deep tank, but you don't care too much about the bottom details. You only care about the splash up above. So the narrow band is going to help reduce this the compute time at the areas where you don't see or need the fluid. But in these cases where you have flooding or shallow water, like a seashore or anything like that, the narrowband is not going to work, but I'll cover it. And then inside the solver, we have to make sure that this option, which is off by default now, is off. So just in case, I'm going to leave everything to default. I'm going to increase this to 0.05, and let's hit play. I want to make one source stronger than the other, like quite a bit different. And right now they both feel the same. So I'm gonna double this. It's gonna be much stronger now. I'm gonna push this along the negative y to have it splash faster or hit the water harder. Sorry, the geometry harder. I want to get variation between these two guys. That's pretty much it, what I'm looking for. And then as they mix, they will also create more interesting details. You can see the details here already. And the more, if you see coloration variation or color variation between the points, that's a good indication. It means there is a speed or height variation, or they're moving in different ways, and that can be reflected when we generate the mesh. Okay, so what I'm going to do, let's check the point count. Let's go up. Come on. Okay, let's import this. So I'm gonna copy this chain and let's import this guy. Okay, we have 1.5 million. And you see the resolution here of the fluid, and we're gonna cache that to disk. Actually, this node now doesn't exist, so let's copy it from here. Not sure why it doesn't exist. Should, but we're gonna paste relative reference to the correct area, and I'm gonna write it to a different location. And I'm gonna call this flood v1. I'm gonna cache 80 frames only, and let me make sure that this path resolves. If I middle click now, it doesn't resolve, so I need to declare it here, and let's do that. Cool. That should be fine. And I'm gonna lower this to 1. And let's hit save. We'll continue in the next video. Thank you guys for watching, and see you in a bit.